Now that you've learned the relationship between moles and particles and moles and grams, we're going to talk a little bit about gases and the moles and volume relationship. Remember, it would be impossible to count the amount of particles in a mole, especially of a gas, and so we have to use other units, like milliliters and liters, to measure the amount of gas. What scientists have learned is that no matter what gas you are, if you are in the amount of 1 mole, and you are at standard temperature and pressure conditions, abbreviated as STP, you will contain 22.4 liters of volume. That is called the molar volume of a gas. And once again, 1 mole of any gas will equal 22.4 liters of that gas at STP. You must be at standard temperature and pressure conditions. You can see with the 3 balloons below of helium, oxygen, and nitrogen that when they are at 1 atm and 273 Kelvin, which is standard pressure and temperature, they have the same volume of 22.4 liters. Remember that they will have different molar masses. 1 mole of helium weighs 4 grams of helium, 1 mole of oxygen weighs 32 grams of oxygen, and 1 mole of nitrogen weighs 28 grams of nitrogen. It's hard to fathom what 22.4 liters in volume would look like, so let me help you out. It's about the same volume as 3 basketballs. When doing calculations, remember you will use the conversion factor 1 mole equals 22.4 liters. Remember you will express it as a ratio using the form of dimensional analysis. You may either use 22.4 liters per 1 mole or 1 mole per 22.4 liters. It just depends on what you're starting with. If you're going to start with a certain amount of moles of gas, we would use the conversion factor on the left. However, if we were starting with a certain volume of gas, we would go ahead and use the second conversion factor, converting to moles. Let's go ahead and try an example. An experiment requires 0.0580 moles of NO. What volume would you need at STP? So we're going to start off this problem by recognizing the amount given in the problem, which is moles of NO. We know that's a gas. We know we're at conditions of STP, and I'm asking you to go to volume. So knowing that 1 mole of any gas is equal to 22.4 liters of that same gas at STP, I'm going to go ahead and convert to liters. So we'll take my amount, 0.0580 moles. I'm going to go ahead and do my T-chart. I'm going to get rid of moles of NO, and I'm going to go to liters of NO. I know that 1 mole is 22.4 liters. I'm going to go ahead and cross out anything that's similar, multiply everything on top, and I end up getting 1.2992 liters. Taken to 3 sig figs, which is the least number of sig figs in the problem, would be 1.30 liters of NO as my final answer. Let's try another problem, but let's kick it up a notch. Suppose you need 4.22 grams of chlorine. What volume at STP would you use? So we're going to go ahead and identify our starting amount, which is 4.22 grams of chlorine. And you can see that we're trying to figure out volume again, and we're at the conditions of STP. Since chlorine is a gas, I'm going to go to liters of chlorine gas. So of course we're going to start off with our 4.22 grams of chlorine, and we're going to do our dimensional analysis T-chart. We're going to get rid of grams of chlorine, and we need to go to liters, but we do not have a relationship between grams and liters of chlorine gas. We have the relationship we just spoke about, where moles are equal to liters, but we also have that relationship where 1 mole is equal to molar mass. So you can see that the gram-liter relationship are actually in 2 different conversion factors, but they're both equal to a mole. So when in doubt, always go to the mole as the unit of change. So you can see moles in grams. We're going to use the first conversion factor. 1 mole is equal to the molar mass of chlorine, which is 70.90 grams. Remember how I'm getting that number? I'm looking on my periodic table. There are 2 chlorine atoms. Each one has an atomic mass of 35.5 0.45 grams, which is giving me the 70.90. I'm then going to convert the moles of chlorine gas to liters of chlorine gas using the second conversion factor. 1 mole equals 22.4 liters. We go ahead and we cross out any units that are the same across the board, and we do the math. 4.22 times 1 times 22.4 divided by 70.90. We end up getting to 3 sig figs, 1.33 liters of chlorine gas. This concludes our unit on the mole. We learned 3 very important conversion factors, and it's going to be your job in class to figure out which one to use appropriately as you are asked many different questions dealing with converting between the units of moles and mass, particles, and volume. See you in class.